Hey, 8th grade. So today we're going to start talking about convection currents and plate tectonics as a whole. So the first thing we're going to talk about is the layers of the Earth. And we're going to relate those to a few different things. One of that is temperature. The further you go into the Earth, the hotter it gets. Every 40 meters that you descend, it gets a 1 degree Celsius hotter. So as you go deeper into the Earth, the hotter it gets. The further you go into the Earth, the higher the pressure and the density. So the temperature, the pressure, and the density all increase as you go into the Earth, from the outer core all the way into the inner core, from the crust all the way into the core. This is the same as if you're swimming in a swimming pool and you swim to the bottom. That pressure change is what actually makes your ears pop. So there's a couple layers when we're talking about the Earth, and one is called the lithosphere. And the lithosphere is the uppermost part of the mantle as well as the crust. The crust is that layer of solid rock that includes both dry land and ocean floor. And its composition is different depending on if you're going through the ocean or dry land. The ocean has a much more dense crust layer. The uppermost part of the mantle is very similar to the crust, and this with the crust forms the lithosphere. Underneath the crust, we have a convecting mantle. And what this means is that there's convection currents going on within the mantle due to the differences in temperature once you get closer to the core or closer to the crust. So it's softer than the rest of the mantle, and it's there's a tar-like consistency so that it moves slowly and flows. It's still a really hard material, and it would still hurt if you were to kick it. But as you can see in the mantle, as that tar-like material gets closer to the core, it warms up. And as it warms up, it becomes less dense. And this is when that convection current occurs, where it floats up to the surface, up near the crust. As it starts to cool, it then becomes less dense or more dense and starts to sink again. In the middle of the Earth is a dense metallic core, and this is a ball of solid metal surrounded by a layer of molten metal. So this is the inner and the liquid outer core, and it's mostly made up of iron and nickel, and this creates the Earth's magnetic field. The lithosphere is divided into separate plates which move very slowly in response to the mantle. Heat from the mantle and core creates the convection currents that we just saw. If we're to watch this process happen, we can see in this, we have these green plates sliding across. These cracks are where that molten lava can come through, and that's where mountains can be built, and these convection currents are constantly moving. There's a couple different plate boundaries that we're going to talk about. And on Earth, there's 7 major and a bunch of minor lithospheric plates. And the edges of most plates lie beneath the oceans. The 3 types of boundaries are convergent, divergent, and transform. Convergent is when the 2 plates come together or collide. The violence and the pressure at this area can produce mountains, earthquakes, and volcanoes. And the movement of one plate underneath another is called subduction and creates a subduction zone. So you'll notice as this oceanic and continental crust collide, the oceanic, which is more dense, slides underneath that continental, creating subduction. At a divergent boundary, this is when the 2 plates move away from each other. Melted rock from the mantle can seep to the surface at this boundary and form new crust. Most are in the oceans and build undersea mountain ranges called mid-ocean ridges. And the last one we have is transform, and this forms where 2 plates slide past each other. When sliding rocks grind against each other, it creates a jolt known as an earthquake. So here we see in the lithosphere, we have divergent plate boundary where we have the spreading apart. Once that pushes that old crust into that continental crust, you have a subduction zone. You'll also notice here we have things like hot spots, which is just cracks coming up, which can create these volcanoes. We also have volcanoes at the convergent boundary, and there's a divergent plate boundary on land as well. When 2 plates collide, we call this a convergent boundary. This is an example of a divergent boundary. Earthquakes occur at transform boundaries. When plates slip past each other, We call this a transform boundary. This is an example of a convergent boundary. Volcanoes form at convergent boundaries. This is an example of a transform boundary. When plates move away from each other, this is called a divergent boundary. If new crust is formed, this happens at the divergent boundary. Part of the Earth that has the least amount of pressure, the crust. Part of the Earth that has the highest temperature, the core. Part of the Earth that moves very slowly, the mantle. Part of the Earth that is described as a solid metal ball, inner core. Part of the Earth that has the highest amount of pressure, the core. Part of the Earth that contains the upper mantle and the crust, the lithosphere. Go ahead and move on to your practice questions for today on exitticket.com.